as we saw much earlier in the class, one way to compare algorithms is to choose a cost model and then compute its order of growth based on that cost model. See what we can learn. So what we're going to do here is pick a cost model, in particular the number of characters examined. Okay. Now by examined here, what I mean is that when it comes to radix sort, you have to count all of the occurrences of each character. So if I have 400 spades, I'm going to do 400 character examinations in order to compute that 400. Okay. And then in merge sort, what I mean by an examination is every time you need to call character at in order to compare two strings. So as you're comparing two strings, each letter you look at in the string, that's a call to char at. Now, if these definitions don't quite make sense, don't worry about it, because I'm going to give you some problems that I'll work through to make them very clear. But our cost model is the number of characters that we examine. So let's start with MSD radix sort. Actually, in this case, since the strings are equal, doesn't matter if it's LSD or MSD, but I'm going to use MSD radix sort. So let's suppose we have 100 strings that are 1,000 characters each. What I'd like you to do is to estimate or compute exactly, if you can, the total number of characters that are examined by MSD radix sort in the in the process of running. And you're going to assume that all strings are equal. Okay. So this one actually turns out is a straightforward problem. Maybe the way it was stated was not straightforward, but for MSD radix sort, in the worst case where all strings are equal, every character will be examined exactly once. So you do a counting sort on the most significant digit, and each of those characters gets examined once. Then, when we move to the next column over, or the second character, then we do a counting sort on that, and so forth. And so overall, we will do a total of 100,000 total character examinations. Okay, so that's MSD radix sort. The cost, in terms of our cost model, is 100,000 character examinations, or character at calls. Okay. All right. How about merge sort? This one's a lot trickier. So what I'd like you to do is try to estimate the total number of characters that are examined by merge sort if all the strings are equal, if we have 100 strings of 1,000 characters each. Now, what I'm going to do in a moment is spoil the first half of the problem. If you want to try and work it out from scratch without any spoilers, go for it. Otherwise, try and make some progress, and then I'll give you a really important hint. Okay, so the important hint is going to be to figure out the cost per merge operation. And so I'll start with, let's say we want to merge 100 items. Okay, so we have 100 strings, and we're going to assume that they're all equal. And what we're going to also assume is that when two strings are considered equal, or two items are considered equal, we're always going to pick the left when it comes to the merge. So remember, merge sort, you look at two items and the smaller one gets copied, and then you advance a pointer. So I'm going to say if they're equal, you're always going to keep advancing the left pointer. So in order to compare A0 to A50, when we're doing our merge with the left half and the right half at the top level, when we do this comparison, we have to compare this string of length 100 to this string of length 100. And so in order to do that, each string is length 1,000. So in order to do that, I need to look at 2,000 different characters, AA, and so forth. So I spend 2,000 character examinations comparing 0 and 50, and that tells me, okay, this one is less than or equal to, so we'll copy it and advance this pointer. In order to compare I equals 1 to j equals 50, we do another 2,000 characters, and then another 2,000 characters, and so forth. We do that 50 times for a total of 100,000 characters examined in order to do this single merge operation. At that point, you no longer need to look at the characters in the right half because there's nothing left in the left half, so you're just going to copy all of these over. And so if we generalize this pattern, the total number of characters examined will be n over 2, that is all of the left half strings, times 2,000, because for each of those pairwise comparisons, we're doing 2,000 character examinations, since all the strings are equal. If the strings were not equal, it's possible that maybe the top character would differ and it would be cheaper, but here, since I said all the strings are equal, it's going to be exactly 2,000. Okay, so what does this tell us? Well, I'm going back to that problem I had before. So in the previous slide, I showed you that merging in strings of 1,000 characters requires 1,000 end examinations. Okay? So now you need to think about all the different merge operations that occur, and that will give you a way to estimate the total number of characters examined by merge sort. So think about that problem again, and now with this hint, I think you should be able to handle it. The previous problem was pretty tricky, and I'll give you the answer away in the next video.